Human eye and colorful world. Hypermetropia is the second type of disease, eye disease. The person who is suffering from this type of disease, he can see all the objects which are kept at infinite distance, but the problem is he cannot see the nearby objects. Actually, healthy eye can see all the objects which are kept at 25 centimeters from the eye lens. This is the least distance of the distinct vision. This is for the healthy eye, it is 25 centimeters. But a person who is suffering from hypermetropia, this distance is not 25, it is more than 30 centimeters. He can see if it is kept at 30 centimeters. Let us say, for a person who is suffering from this type of disease, he can see the object which is kept at 30 centimeters. That is the problem for him. If it is moved towards this, towards L, if it is kept between these two, he cannot see the object clearly. He can see all objects which are kept away from this point, whose distance is more than 30 centimeters to infinite. He can see all the objects. And if it is kept here, image will be formed on the retina, no problem to see the object. But the problem is when an object is kept between H and L. If it is kept here, there the person faces the problem. He cannot see this image of this object clearly because image will be formed beyond the retina. That is the problem. To rectify this problem, let us see which lens we have to use. Here, object is kept here. This is O. Blue color lines represent the incident rays. These are the actual path of the incident rays. When these rays enters into this concave lens, their paths tend to diverge. Their path tend to move a little bit away from the principal axis. So this is called diverging. If you consider a parallel beam of light rays, this is the original path. After traveling through this lens, they tend to move away from the original path, away from the principal axis, like this. If you want to find the image of this object which is at infinite distance, we have to extend these two lines like this. You will get image here at focus. So when the rays are traveling through this lens, concave lens, they tend to diverge. So they are called as diverging lens. Here the object is here, and if you want to get the image near the lens, then you go for concave lens. Object is at more distance and you want to see the image near the lens, then you go for concave lens. And second type of lens is converging lens. It is convex lens. Here the object, this is O, object. These are the two rays traveling through the convex lens. When these two travel through this lens, after refraction they tend to move towards the principal axis little bit. If you consider parallel rays, they converge at point F. This is F, the focus of the convex lens. So parallel rays are converging at this point, therefore this lens is called as converging lens. So when you consider a point source, here the object, if you want to get the image away from the lens, then you go for convex lens. This is called as the converging lens. So in this example, what we have is, so object is at this point. For this diseased eye, we need to get the image away from the lens at point H. Then we should go for convex lens. Then we go for the convex lens. Here the object, and we need image at this point away from the lens, so we should go for convex lens. Now let us see how we can rectify this problem. Step 1. Get the image at point H. Here the object, I want to keep the object at 25 centimeters here, and I want to make him to see this object. For that I use a convex lens. This lens makes the image to form at the point H. Image will be formed at this point. In step 2, get the sharp image on the retina. Initially object is at this point. Using the lens we get the image at point H. This image becomes the object to our eye lens. When object is here, this diseased eye can see it very clearly. Therefore image will be formed at retina. The problem is cleared. That's it. Now let us find what is the focal length of the lens to be used to rectify this disease.